So what do you got for me tonight?
We're adding, subtracting, and multiplying radicals.
Okay. Go ahead and give me a problem. Oh, hold on a second. One moment. Keep forgetting I have to do this. Okay.
Alright. Alright, so 6 radical 6 plus 4 radical 6.
What's this?
I didn't really learn it yet. It's just
Okay.
like you told us we are gonna learn it next class, so
Here's what I want you to consider. Radical 6 equals 1 apple. Okay? So this means you got 6 apples, and you're adding 4 apples to it. So how many apples do you have?
10 apples?
10 radical 6. Yeah.
Right.
In other words, just treat radical 6 as something, and you got 6 of them plus 4 of them. So you got 10 of them total.
Right.
Okay, what else? Now, having said that, you can only add like terms. I cannot add those two together. Because this is an apple, but this is an orange. I cannot add apples to oranges.
Right.
The only times you can add those radicals is if they are the same. You can multiply apples and oranges. Still an apple, that's an orange, but I can multiply. When I multiply, what do I get?
Radical 6.
Yep. All right, what other problems do you have?
9 radical 7 minus radical 28.
Minus radical 28?
Mm-hmm.
Okay, notice these are different. This appears, radical 7 is an apple, radical 28 is something else, a pear. But let's simplify radical 28. Maybe something nice will happen. How do you simplify it?
Well,
split it apart by factoring it.
I'd do 4 and 7, and then, it'd be
Now
2 root 7.
simplify it. What do we have?
2 root 7.
And now finish it.
And that would be 7 root 7.
There you go. And all of these problems like this are going to be like this, where, in other words, once this is simplified, it's going to have a root 7 in it. So that gives you a bit of an advantage, and you know that 7 is one of the factors. Because they're not going to give you this problem. Root 29, that's not a doable problem. I mean, you can put it into a calculator and come up with a decimal number, but they don't want decimal numbers. They want radical answers.
Right.
All right. What else?
Radical 3, parentheses, radical 6 minus radical 3.
Okay. What's the first thing we should probably do?
Distribute.
Okay. What do you get?
Radical 18 minus radical 9.
Simplify radical 18.
Oh my god. So it'd be 6 and 3.
Neither 6 nor 3 is a perfect square number. We have to simplify it by finding a factor that is a perfect.
9 and 2, sorry.
Okay. So that becomes 3 root 2, right?
And
Because
then
the 9
minus
comes out as a 3. And then minus what? What's square root of 9?
3.
Okay. So that actually is our answer right there. And that is the way it is expressed. Now,
Okay.
you could also factor out a 3 and end up with something like that. You could also express it like that. But there's really no need to factor if it doesn't gain you anything. So it's unlikely that you would find that on a multiple choice test. More likely you would find this one over here. And if you had to give the answer without multiple choice, you'd give the one on the left. Only factor if it benefits you. In other words, if it allows you to simplify it further.
Okay.
Okay, what else?
Alright. So 4 root 7 parentheses radical 10 minus 3 radical 6.
Like that?
Yep.
Okay. First step?
Distribute.
Okay, what do you get?
So what do you do? Like, would it be like 4 root 70 or?
You got it. Perfect.
Okay. And then the other one would be minus 12 root 42.
Okay. Now, since this 70 is an apple and 42 is an orange, we need to simplify this, and hopefully it'll come out to be something the same. Well, let's talk about factors of 70. I don't see any perfect squares in there.
I don't either.
So, I can't really simplify it, but I could write it like this. Right? It is root 7 times root 10. And then what about the 42? I can't simplify that. There are no perfect square factors, but there is a root 7 in there. Times what?
6.
Root 6. Okay.
Root 6, sorry.
So now I've got this to deal with. Well, is there a greatest common factor?
No.
Actually, there is. Root 7. In fact, 4 root 7. What's that leave behind? It just gets us back to the beginning. That doesn't do anything. So the question is what do they want you to do here? If I break it down all the way, there's the 3 prime factors. There's the 3 prime factors.
Okay.
Now, I could take out a root 7, a 4 times a root 7 times a root 2. So if I were to look for the greatest common factor, it would be that. What's that leave behind? Root 5 over there, 3 there, and root 3 there. So we can turn it into that, but I'm not sure that that's any better than what we started with. Are you sure this was the problem? Because this doesn't really do anything. In other words, it doesn't make sense to me why they would give you this problem. We can't
Yeah.
simplify it. It's simplified already.
Yeah, this is the problem.
Okay. I can
So what?
change it. I changed it a little bit. If you look at the bottom, it's not exactly the same as the top, but it isn't really simplified. In other
So
words,
with
there's no
the
advantage. I would say this top answer is just as good an answer as this bottom one.
So would the just regular question be the answer? Or?
I don't know. What was the question on this?
All right. So it says simplify the product, and then it's 4 root 7 parentheses root 10 minus 3 root 6.
Explore?
Explore, what?
Is that what you said?
No, it says simplify the product.
Simplify the product and then do what?
And then the question is 4 root 7 parentheses root 10 minus 3 root 6.
All right, I'm not sure what they're looking for. Possibly this answer on the bottom, although I'd be surprised just because that's not simplified. This answer on the bottom is actually a little bit more complicated than the answer on the top. Notice the answer on the top has got that times these two things, whereas the answer on the bottom's got 3 things times these 2 things. So I don't see the one on the bottom being more simplified than the one on the top. But I can't really do much on the bottom. I don't see anything else I can do. I mean, root 7 times root 2 is root 14. So I could do this times all this other stuff, root 5 minus 3 root 3. Maybe they're looking for that. I don't know. Could try that. It's a little different looking. But this is not a particularly good problem if that indeed is the problem, because it doesn't really simplify. What else you got?
All right. So parentheses 2 root 2. And then in parentheses, and then open parentheses again, 2 minus root 2.
2 minus root 2.
Yeah.
Okay. It's the first thing you're going to do.
Distribute.
Okay.
So would it be 4 and then minus root 4?
Hold on. Multiply those 2 things together. What do you get?
2 root 2.
No, you get 4 root 2.
What?
Well, you multiply the 2 times the 2. It gives you 4 root 2.
Okay.
This term by that term.
All right.
What do you get when you multiply that times that term? It's minus.
2 root 2.
Well, it's not 2
negative.
root 2. It's 2 root 2 root 2. What's root 2 times root 2?
Root 4.
Or, remember the goal is to pull whole numbers out. Root 2 times root 2 is 2. Root x, and this is an important concept. You got to remember this. Root x times root x is x, which means root 7 times root 7 is 7. Root 100 times 100 is 100. Anything, the root of it times the root of that same thing is equal to that thing. So what do we have? We have 2 root 2 times root 2. So that's 2 times 2.
Right.
4. And there's your answer.
Okay.
All right, what else?
Alright,
Have you had, other than square roots, have you had cube roots?
no.
Okay. I won't go there then.
Let me pull this other problem. Alright, this next problem is 4 root 75 plus root 48 minus root 50.
Okay. Let's start simplifying and see if we can come down to something common in the radical sign. So,
Okay.
how do I simplify root 75?
Root 75?
On the left, yeah.
25 and 3.
Okay, so what does that give you? Gives you 4 root 25 root 3. What does that turn into?
That would be 4 root 5 root 3.
It'd be 4 times 5 root 3. That is the number 5. So that becomes 20 root 3.
Right.
Okay, now, what about 48? Is there a root 3 in 48? Because we've already got 1 root 3 over there. Most likely we're going to find another root 3 somewhere.
Right.
So does root 48 simplify into some kind of a root 3? 48 is 16 times 3.
Yeah.
So that becomes 4 root 3. How about root 50?
50, that would be 25 and 2.
Okay, so what does that become?
5 root 2.
Okay. Now let's simplify that as much as we can. How many root 3's do we have?
We have 2.
What are they total? Because they're both apples. That's an apple and that's an apple. This is an orange over here. We can't add it, but we can add apples together. How many total apples do we have?
2? Wait, what?
We got 20 apples.
6?
We got 20 apples plus 4 apples.
Mm-hmm.
How many apples do we have?
What?
We have 20 apples plus 4 apples.
24.
Okay, that's your answer. And an apple is a root 3. So those two combine by just adding. They're both root 3's. So you got 20 root 3's and you got 4 more root 3's. You got 24 root 3's. Now, I cannot subtract root 2 from root 3. So this has to be my final answer.
Mm-hmm.
Because this is an apple, this is an orange.
Right.
Okay, what else?
Alright, so n squared minus 6n plus 9 equals 2.
They just want you to solve this for n?
Yeah.
It's the first step.
When you set it equal to 0, so move 2 to the other side, or?
Well, yeah, you're right. You want to set it equal to 0. How do I do that? What's it equal to now?
-2.
Yeah, I got to
2.
subtract 2 from both sides.
Right.
Now it's equal to 0. Now I can factor it and try to solve it.
Mm-hmm.
Does it factor?
So it'd be
Both sides have to
-7
be
plus
negative.
Oh yeah.
Now, are there factors of 7 that add to the number 6?
Yeah.
No, there are not. 7 and 1 subtract to the number 6, but because this is a plus sign, I need it to add to the number 6.
Right.
Which means I can't factor this the way it is. Let's go back and start. Now, this is kind of unusual, but can you factor the left side? This is not usually what you do. I'm not sure why they're giving you this problem. I see it as a little almost detrimental, even though it's going to allow us to solve this thing. Can you factor n squared minus 6n plus 9?
Yeah.
Both signs are what?
Negatives.
Factors of 9 that add to 6.
3.
Now notice I can, and this is unique to this problem, but I can write this like this. And now I can solve this thing by taking the square root of both sides. So in this particular problem, the best way to do it is to not set it equal to 0, which is almost never the case that you would want to do a problem like that. But nonetheless, let's take this to its conclusion. What's the next step? What else? What am I going to do at this point? When you have something squared.
Oh, square root it.
Okay. So, what's the next line?
N minus 3 equals root 2.
What are the first words out of your mouth need to be when you're taking the square root of both sides? What else?
And then it'd be negative or 3 plus minus root 2.
And that's the answer. Notice we did not have to apply the quadratic formula. If we do this the normal way and we get n squared minus 7n plus 7 equals 0, that's the normal way to do it. We discover that we can't factor it, and we apply the quadratic formula. Well, guess what? After we apply the quadratic formula, this is the answer we get. The quadratic formula was actually developed more from this technique on this problem than anything else. It's a complete the square formula that was developed. Okay, we got time for one more. Where else?
Let's see. Okay, so here's like a word problem one.
Okay.
A jogger goes 0.5 kilometers west and then turns south. If the jogger finishes 1.3 kilometers from the starting point, how far south did the jogger go?
Okay, so let's draw a picture. Okay, he starts right there. Which way is west?
Left.
Okay, so he goes west for 0.5. And then what does he do? He turns south?
He finishes, yeah, and then he turns south, yeah.
So he finishes south. And what they're saying is that the distance that he is away from his starting point is what?
1.3.
So all you have to do is solve this triangle. And they want to know how far south he went?
Yep.
What kind of triangle is this?
Right triangle.
Yeah, it's a special kind of right triangle. You have a 3, 4, 5 right triangle. That's your lowest. What's the next lowest? In other words, these right triangles keep showing up in geometry. So it's really good if you learn them. Because you're going to deal with them so much that... Does that look familiar right there? There's your lowest 2 right there. If you just memorize these 2, that's going to take care of 90% of the triangles you run into in your life. Just those 2, in terms of not having to apply the Pythagorean theorem. So what's my missing side over here? Well, almost. It's not 12. What is it?
13?
No.
Wait, what?
Here's a 5, 12, 13 triangle. This is also a 5, 12, 13 triangle. Only it's not 5, 12, it's 0.5, 1.2, and 1.3.
Yeah, 1.2.
In other words, these 2 triangles don't always come in these proportions. It's proportional. In other words, you may find a 30, 40, 50 right triangle. Or you may find a 50, 120, 130 right triangle. So we can tell by looking at this 0.5 and 1.3 that we're looking at the 5, 12, 13 triangle. Just got to make sure I get my decimal point in the right spot. So it's 1.2. Is how far south he must have traveled.
Yep.
All right, Blake, I will let you go, and I believe we have a session either tomorrow or the next day. Yeah, it looks like tomorrow. Talk to you at 7 tomorrow night.
Yep.
Talk to you then.
Yep.
Have a good one. Bye-bye.
You too.